Okay, we're going to start our unit on congruent triangles. And as we begin our first unit, we're just going to take a look at the basics of triangles, the different properties that we can identify and use as we work through solving problems involving triangles. Okay, so the first thing we're going to take a look at is what is known as the triangle angle sum theorem. So we're going to take a look and explore on GeoGebra and figure out uh, how many degrees are in a triangle and kind of show you a way to prove that. If you don't know how many degrees are in the sum of the degrees in a triangle. Okay, so you can see on this triangle here we have triangle ABC with about 65 degrees, about 62, and about 53. I can rotate the triangle so that angle C goes down by angle A, and I can rotate the triangle so angle B is down by angles A and C. And you can see what happens with all three of those angles. They form a straight line, which you all know is 180 degrees. And notice what happens no matter what I do to the angles, or how I shrink the triangle or change it, those three angles always have a sum of 180 degrees. Okay, so that's something very important, important property of triangles, that their sum is always 180 degrees. We're also going to look at the exterior angle sum theorem. So the exterior angle sum theorem deals with the exterior angle, and that would be the angle that's on the outside of the triangle. After this loads up, we'll play around with it and see what happens. So this exterior angle, the angle that is a linear pair with angle B here, if the line AB were extended out, we want to see what this angle has to do in connection with the other angles. Well, we know this angle, if I were to extend that line out, we would see that this angle is a linear pair with this one. They're supplementary. And notice what happens when I translate the triangle over. Angle A gets translated over here. And notice I can change the size. It doesn't affect angle A too much. But then if I flip the triangle and rotate it, notice what happens to angle C. Notice angle C and angle A equal angle B. And so, that's the exterior angle theorem, is that those two angles, move it back, I can change the triangle size if I want, but those two interior angles, the two non-adjacent interior angles, are equal to the exterior angle. And we can prove that in multiple ways, but it's good to visualize it here and see how it works. And I can change the size of those, but no matter what I do, if I flip that angle down there and translate this one over, those two are the same. And so we can see that will always be true, because this exterior angle adds up to 180 with this one, and the three of these interior angles add up to 180. So this angle's supplementary with these two, whereas this red angle is supplementary with angle C. So that's another important bit of information that we'll need to apply with triangles. Probably want to write that down. Get my pen out. Sum of the measures of the interior angles of triangles 180 degrees. So in our example over here, measure of A plus measure of B plus measure of angle C is 180 degrees. The exterior angle theorem, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. And so if we take a look in our diagram, angle 1 here is the exterior angle. Angle C would be the adjacent angle, so B and A are the two non-adjacent interior angles. And then just some basics of triangles, some terminology that you've probably learned before, but it's important to put down in writing. A scalene triangle has 0 congruent sides. These are all ones we classify by their sides. Isosceles, as you can tell by the diagram, has at least two congruent sides. Equilateral, all sides are congruent. And if we classify triangles by their angles, an acute triangle has all three angles acute. The right triangle has one right angle. The obtuse triangle has one obtuse angle. The equiangular triangle looks just like the equilateral triangle. It has three congruent angles. And since there is sum of 180 degrees, each angle would have to be 60 degrees in order for them all to be the same. So just remember that when you're talking about different triangles, know how to classify them by their sides, scalene, equilateral, and isosceles, and also be able to tell by their angles, acute, obtuse, right, and equiangular. So let's take a look at this triangle here. The triangular shape, the shuffleboard scoring area. Let's classify it by its sides and angles. So I can see by the diagram that there are two congruent sides. So we call that isosceles. And by measuring the angles, we can see that they are all less than 90. So we would say it's an acute triangle. Take the time to try to draw an isosceles right triangle, and then also draw an obtuse scalene triangle. I'm going to draw an example, and you can see if yours matches up. So the isosceles right means two sides are the same. I've got one right angle. Make sure I label my diagram correctly. And an obtuse scalene, so all sides are different. And it's not a very well drawn line. We've got one obtuse angle. Maybe I should draw a better one. That's not a whole lot better. Probably should just move on. All right. So if the triangle is on the coordinate plane, we can also classify it and determine if it's a right triangle. So the way we would do that is we'd have to find a right angle. Well, I know Q is not a right angle just by looking at it, so it could be angle P, but that doesn't look right either. But angle O looks like it could be a right angle. So I could tell if these two lines are perpendicular because I know perpendicular lines form a right angle. So if I can compare the slopes, so the slope of line PO, well, that slope is down 2/1. And the slope of the other line, line OQ, and we can compare that slope. That one goes up, let's see, over 1, 2, 3, 4, 5, 6, up 3. So 3 rise, run of 6 equals a half. And I see -2 and 1/2 are opposite reciprocals because -2 times 1/2 equals -1. Therefore, these lines are parallel, which means that's a right angle. So yes, that would be a right triangle. Now, let's apply what we know about the triangle sum theorems and exterior angle theorems, and let's see if we can find the indicated angle measure. So we want to find the measure of angle JKM. Why don't you pause the video and see if you can find the connection and create an equation to find that angle measure. Restart it when you're ready. Okay, so I know angle JKM is an exterior angle. It would be equivalent to the sum of the two non-adjacent interior angles. So I set up my equation and found x equals 75. Plug that back into the equation to get 145. Bottom one, I know all three angles add up to 180 degrees. So I set up my equation, solve to find x is 32. Then I can put x, or 32 back in for x to find 64 degrees and 26 degrees. Okay. Now let's take a look at isosceles triangles and equilateral triangles and see which kind of special properties those triangles have when we take a look at them. Okay, so we can see ABC is an isosceles triangle. And as we take a look at the measurements of the angles, I see angle A is 50.91. Angles B and C are both 64.54. And the measurements, AB is 13.29, so is AC. And BC is 11.43. So we know that isosceles triangles, we have at least two sides congruent. And as we look at that, if we change the shape, notice we still keep these two sides congruent. What else do you notice when I change the shape of the isosceles triangle? Hopefully you're seeing that, yes, angles B and C remain constant. So that is a property of the isosceles triangle that is important to know, is that the two legs are congruent, and then the base angles, the base is the one leg that's not the same, and the two angles formed by the leg and the base will also be congruent in any kind of isosceles triangle. We call the angle at the top the vertex angle, the one that's different. So our base angles theorem, if two sides of a triangle are congruent, the angles opposite them are congruent. So if AB is congruent to AC, and angle B is congruent to angle C. Then the converse of that would also be true. Two angles of a triangle are congruent. So if angle B and angle C are congruent, then AB is congruent to AC. Okay, so that's an important property that we will work with. So triangle DEF, DE is congruent to DF. Therefore, what are the two congruent angles? Well, angle E would be congruent to angle F. Okay, so the corollary to the base angles theorem says that if a triangle is equilateral, then, as we mentioned earlier, where are we? Here we go. So the equilateral triangle, if it's equilateral, what else is true? It's equiangular. It's equiangular, what else is true? It's equilateral. So that is something else that we can put down in writing. The corollary to the base angles theorem, if it's equilateral, then it's equiangular. Because if all sides, oops, spelled that wrong. If all sides are congruent, the only way that we can form a triangle is if all the angles are 60 degrees. Angular. And if it's equiangular, the converse of this, it is equilateral. And we can see in the diagram over there of our equilateral triangle. So that's important to know. If it's equilateral, it's also always going to be equiangular, and vice versa. So if we take a look at this equilateral triangle, it's equilateral because all three sides are congruent. I want to find the measures of angles P, Q, and R. I could pull out my protractor and measure, or I could just say angle P equals 60 degrees, which is equal to angle Q, say the measure of angle P, and that's also equal to the measure of angle R. They're all equal to 60. Now let's take some equilateral and isosceles triangles and see if we can find the missing values. So why don't you pause the video at this point and see if you can find the values for X and Y. Restart it when you're ready. Alright, so if we take a look at the diagram, we see that we have an equilateral triangle up here. Since all the angles are equal, it's equiangular, therefore all the sides are equal. So Y is the same as 4. And down here, the other one, we've got an isosceles triangle because the base angles are congruent. If the base angles are congruent, these sides are congruent. So since this one is, all these are 4, this one is also 4. So 3 plus 1 is 4. So X is 3. All right, so that's all that we have on triangles, the basics of triangles. We learned how to classify them by sides and by their angles. The triangle sum theorem, that all the angles of a triangle add up to 180 degrees. The exterior angle theorem, that states that the exterior angles equal to the sum of the two non-adjacent interior angles. We also looked at properties of isosceles and equilateral triangles. So we get to close with learning about Triangle Man. You know, he's better than everyone else. So enjoy this song by
Particle man, doing the things a particle can. What's he like? It's not important. Particle man, is he a dot or is he a speck? When does the water get him instead? Nobody knows. Particle Man. Triangle Man, Triangle Man, Triangle Man hates Particle Man. They have a fight. Triangle wins. Triangle Man. Universe Man, size of the entire universe man, usually kind to smaller man. Universe Man, he's got a watch with a minute hand, millennium hand, and a crown hand. And when they meet, it's a happy land. Powerful man, Universe Man. Person Man, hit on the head with a frying pan, lives his life in a garbage can. Person Man. Is he depressed or is he a mess? Does he feel totally worthless? Who came up with Person Man? Degraded man, Person Man. Triangle Man, Triangle Man, Triangle Man hates Person Man. They have a fight, Triangle wins, Triangle Man.
They might be giants.